Hey everybody! The purpose of this video is to get you some solutions to this quiz about rock, paper, scissors, no, heads and tails, taking the trash out. So, the first one, we're playing a best of three because we decided to flip the coin and your friend lost and wants to play best of three. So the question is, assuming you're up by one, what's the chance, what do I ask? What's the chance they'll win in a best of three knowing they're one flip down already? Okay, so there's the flip, they're down. I'm gonna keep this simple. I'm always gonna bet heads and they're always gonna bet tails. It doesn't matter because you're flipping a coin and it's random, but it'll be easier to keep track of as heads is a win for me and tails is a win for them. Makes the tree diagrams a little easier to follow. So if we're playing best of three, let's figure out the possibilities. That's after the first flip. Next flip, one of two things can happen. Either you're gonna flip heads again or you're gonna flip tails again. Okay, now, if you flip heads now, you've won the best of three because you got two heads and the game is over. If you flip tails here, they've won and now you're tied 1-1, which means it goes to a third flip, which goes either heads or tails. So I'm doing this with tree diagrams, and those of you that had me in Math 105, we did these quite a bit. If you didn't have me in 105, it's just an easy way of keeping track of the distributions. So we have to figure out the likelihood of all of this stuff happening. This is a done deal. We knew that happened. So that has a 100% chance of happening. Everything else is supposition. What if? What if? So what if? How likely would it be that you flipped heads right here? Well, half the time you're going to. After this certain heads here, half the time you're going to get heads, and this half of the time you're going to get tails. So far so good. They sum to 100% like they're supposed to. Same thing here. Same thing here as well. Each of these is 1/2 likely. The kicker is, you have to look at the end of the game to see the likelihood of any particular thing happening. So here is the end of this game. Let's draw that with, maybe, let's use a different color. Let's use yellow. Okay? So for this to happen, you had to have flipped heads, and then the game is over. Well, the chance of that happening is 1/2. For this particular game to play out, you have to first have the half likelihood of flipping tails and then have the half likelihood of flipping heads. And you know what and means? That's right, multiply. So you got half times a half, which is the quarter. So there's a quarter chance of that particular arrangement happening. Tails followed by heads. And the same thing with tails followed by tails. That's going to be a half of a half, or also a quarter. Now the kicker is, you have to ask yourself, which one of those games did your friend win? Well, you won this one because you followed the heads with nothing, because you were done. You already won heads up. Here, you won this one because it went heads, tails, heads. So this is also your win. This is your friend's win right here. So the chance of your friend winning in a best of three, if he's already down one coin flip, is only 1/4, 25%. Which maybe makes you wonder, why would you do that? Well, you would do it because at least it's something. I mean, otherwise, if you flip your head coin once and he loses, you got to take the trash out. At least he's got a 1/4 chance of not taking the trash out. So anyway, so there's part A. There's part A. Part B paints a different scenario. This is like you're already in your best of three, and your friend has now lost the best of three, heads, tails, heads. So in other words, this just happened. So that's a given now. Those probabilities are 100%, that's what did happen. And then he's like, best of 5! So now the question is, what's the chance your friend is not going to have to take the trash out in a best of 5 game, because we're going to keep this going for a while. Okay, so same logic, right? Same logic. Best of 5 means first person to get to 3 of their coin wins. So here, heads or tails, again, both of which are 1/2 likely. Okay. And then here, you're done. You've already won this one. Tails, it could go heads, or it could go tails. Okay? Both of these are 1/2 likely. You have to view it all as relative. Each one of these branches has a 100% chance of happening. But the string of the heads and tails is what you're interested in, because that's the end of each of the game. And then here, you've won again, and here is the only chance your friend, tails, 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 he's won here, and, oh, I think we're done, actually. Yeah, we're done. Because it went heads, 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 and you've won, and then tails, 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 and he's won. Or he or she, I guess I shouldn't be gender specific. Okay, so now let's figure out the chance of your friend winning now. So if you flip heads on your next flip, which is going to happen half the time, your friend has to take the trash out, assuming that he doesn't call for a best of 7 or something silly like that. Okay? If, I should use yellow. I'm sorry. That's better. If it goes heads, tails, heads, tails, heads, which is one of those nail biters, well, that has a half of a chance of happening, which is, again, 1/4. And then finally, heads, tails, heads, tails, tails. Okay, it's alternating, but then he pulls it out at the very end and goes to tails. Well, guess what? That also has a 1/4 chance of winning. So once again, calling for a best of 5 doesn't raise the chances of him taking the trash out any less because of the fact that it's still a 1/4 chance of winning. Of course, remember, if you keep replicating these two situations, eventually he or she is going to win based on a law of large numbers, but of course you're probably going to win first. So you can see keeping the game alive. But that's not what part C asks. Part C asks, what happens if your friend doesn't get that tail in the middle of the first best of 3? So you win on heads, heads. What happens then? Does anything interesting happen? Let's see. Let's see. Okay? So it's kind of boring at first because it progresses kind of the same. Might flip heads, in which case you've won because that's 3 heads in a row, best of 5. Or he or she might flip tails, which again, half and half. Okay? Now, we're going to chase this branch here because this is the only one where anything interesting is happening. You could also flip heads again or tails again, which again, this branch looks just like the one up here. You got half here, and you got half here. So here, heads, 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 you've won, game over, he takes the trash out. Here, heads, heads, tails, tails, and again, he or she is still alive because you've got heads, heads, tails, tails. And you can tell that at this point right here, this is where the decision is made. If it goes heads, heads, tails, tails, it's a best of 5 series. Whoever wins the next flip wins. Both of which are a half. All right. So it's cool. They're asymmetric tree diagrams because you have these cool little, they only grow in one direction. Okay, so here, I'm using the wrong color. I should be using blue. I apologize. I will start that right now. Here, I'm also going to draw a line here. I was trying to prevent this from happening. You've got a 1/2 chance of winning on that first branch. You've got a 1/2 chance of winning. Here, 1/2 of a half gives you an additional 1/4. And here's where it gets interesting. Here's where that tails actually was valuable to him back here in between. You could still pull it out with heads, heads, tails, tails, heads here. Half, half, half is an additional 1/8. Which means your friend, the only way your friend can win, which makes sense if you're up by 2, is if they go tails, tails, tails for the win. 3 tails in a row. Which is only going to happen 1/8 of the time. And I've got my colors all mixed up. I apologize. It's like a Technicolor vomit. I apologize. But that's the chance right now that your friend, if they're not up with that one tail back there in the original best of 3, they're only going to win 1/8 at a time. They're only going to win 1/8 at a time. The problem, of course, is you're going to win the other 7/8. So, I mean, theoretically speaking, Gambler's Ruin-esque-ish, I just said esque-ish. You could keep this game, they could keep this game going if you keep agreeing to coin flips and banking on the fact that eventually they're going to get one of those flips of tail runs of tail flips in a row, and therefore you got to take the trash out and they don't. But it's just not likely. So 1/4, 1/4, 1/8. And that's just a fun way of doing it. Please notice, if you're not using tree diagrams, you have to come up with these probabilities in some other way. And really the only other way, and this is why the trees help, is to actually sit down and list out all the possibilities, which the trees do for you. That's what makes it kind of nice. But realize too why they're distributions. They all sum to 100%. A half plus a fourth plus a fourth, a half plus a fourth plus a fourth, a half, a fourth, an eighth, and an eighth. They all sum to 100%. And ask yourself why, because they take care of all of the possibilities in all the experiments. So I encourage you, explore best of 7 or best of 9, but don't explore it too much because it gets tedious after a while. You need a bigger chalkboard. Hope that helped. See you in class.